Okay, so we get something like this, right? Okay? Now, your picture might differ from this, and it might be more accurate than mine. And of course, you know, we could work out a much more accurate picture if we did something like this. Because what we're talking about would be actually modeling a continuous line of charges. So we take whatever the total charge is between here and here and divide it up into a bunch of smaller charges. Okay? So these charges would each be smaller than each of these because there are more of them, and they got to total up to the same charge. Okay? But we would get a more accurate model, and we could say, okay, well, let's see. If we know this distance, and this is going to make Lane happy because he would get to write down equations and stuff,
Yeah,
and evaluate them, right?
Yeah.
And then we have a position here. Let's just say that this is our x-axis, okay? Or let's say, actually, this is the line y equals a. And down here is our x-axis, right? So this point is at the point A, y. Well, we could write down the magnitude and direction of the field as a function of A, y. Okay? And as a matter of fact, we could even take our x-axis and just use a continuous charge distribution. Yes, Nelson?
Would that be XA? Plus that line is Y equal A?
Okay, it's x, it'd be that way. Yeah. Being careless. Okay? But yes, we could put coordinates on this point so that we would get an expression that could apply to any point in the whole plane, right? And then evaluate that at a number of points along here and get our vector. And the expression could even be manipulated to give us the magnitude and angle of that vector, right? So we could easily see the trend of magnitudes and easily see the trend of angles. Okay? And we'd find, well, it looks pretty much like this. Okay? But it would be more accurate. We could even use a continuous distribution and we have our point here, and we take a typical point, typical increment, right? An increment delta x with sample point x star, and set up a sum and approach an integral and get the integral that gives us the field at this point, right? Okay? And then if we had access to computer programming, it'd be very, very simple to program this thing to show us the vector field along here, okay? Now, we don't need that for what we're doing right now, but since we're talking about this model, we could do this, okay?